All right, so since I'm out again today, I'm going to lead you through a handful more problems. So I'm going to kind of pick up where the video left off. Do a handful of problems with you just to give you a little bit more for those, and then you can get into your independent practice for today. So if we go to page 34 in your workbook, all right, the video that you were supposed to watch for today went all the way through problem 4 and then did problems 9, 10, 11, and 12. So I'm going to finish the other 4 problems on this page and then do a couple more on the next page with you. And then hopefully you feel pretty confident about the process and what you need to do moving forward. So let's look at number 5 here. All right, and so when I look at this, once again, knowing that type of function, right, we know this is a linear function, right, and then we want to look at what type of problem do we have. Do we have an addition subtraction problem, or is the major operation addition and subtraction, or excuse me, start over there. Do I have an addition subtraction problem, all right, or do I have a multiplication division problem? So when I look at this particular problem, the main property, all right, is multiplication, right? I have 5 times something is 0. All right, and so that's what I want to try to work with first. And then if I ask myself what's the answer to that fact, right? 5 times what is 0? All right, the answer is x plus 5. So x plus 5 is 0. All right, and now we have an addition subtraction problem that we can solve, right? It's already equal to 0, so we can just do our 0 property. What plus 5 is 0? And the answer is negative 5. All right, so let's take a look at number 6 here. So now when we look at number 6, right, we know that this is an absolute value problem. All right, and now once again, what is the major operation here? And the major operation is multiplication, right? That's what we have. We have 5 times something is 0. So very similar to what we just did on the prior problem. All right, so notice the math fact for problem 5 and problem 6 is exactly the same, right? 5 times 0 is 0. In problem 5, x plus 5 was 0. Now, in problem 6, what changes is that the absolute value of x minus 4 has to be 0. All right, now we have to keep going, right? Now we have to ask ourselves the question, and we have to move inside our absolute value bars, right? What number has an absolute value of 0? And there's only one number that has a distance of 0 from 0, and that is 0. So whatever's inside of the absolute value bars, right, it has to equal to 0. All right, so x minus 4 is equal to 0. All right, and then once again, now we can use the 0 property. We have an addition or subtraction problem. Use that 0 property. All right, what minus 4 is 0? And the answer is positive 4. All right, so let's move on to problem 7 here. So moving down here. All right, so now once again, we see our power of 2 here. So we know this is a quadratic. All right, and so now, once again, look for the overarching property, right? So when I see this, this is really, right, a multiplication problem, all right? Except for equal to 0 now, though, it's 5 times what is 100, right? 5 times what is a 100, all right? And so the answer to that problem is 20. 5 times 20 is 100, all right? So now if I take this away, that means 8 minus x quantity squared has to equal to 20. Now, this is a little bit of a different type of problem. All right, and I probably should have made this 125 just to make it a little bit easier, and that would have given us a nice perfect square here. But here's what's going to happen. All right, so when we look at this, right, I need to know now to move inside those parentheses. I need to know what number squared is 20, but that's not a perfect square. So once again, we're just going to use some estimation here because I know 1 times 1 is 1, right? I know 2 times 2 is 4. I know 3 times 3 is 9. So 4 times 4 is 16, right? So I got to keep going, and now I get to 5 times 5 is 25. So 20 is between 16 and 25. So the number squared that equals to 20 is somewhere between, all right, 4 and 5. All right, and so I'm just going to estimate that, and let's just estimate it as 4.5, make it easy. All right, so somewhere between 4 and 5. Now, remember, this is a quadratic, so we know I'm going to get a positive version, and I'm going to get the negative version of that number as well, right? So that means whatever is inside of here, all right, is going to equal to, all right, positive 4.5 and negative 4.5. So 8 minus x is equal to 4.5, and 8 minus x is going to equal to negative 4.5. All right, and then now we're just going to use our 0 property, right? We got that subtraction problem there. So here I'm going to subtract 4.5 from both sides. All right, 8 minus 4.5 is 3.5 minus x is equal to 0. And now I have that zero property, right? 3.5 minus what is 0? All right, and the answer would be 3.5. So there's my first answer. All right, now when I look at the next problem, use my zero property. I'm going to add 4.5 to make the right side 0. All right, and then 12.5 minus x equals to 0. 12.5 minus what is 0? 12.5 minus 12.5 is 0, so there's my second answer. Now, here's what you have to keep in mind, right? When we have more than just x inside of our square or absolute value, our numbers and our solutions aren't going to just be opposite of each other. And I saw that when I was looking over some of your exit tickets, right? Some of you just put, oh, if it's 3.5, my next answer has to be negative 3.5. And that's not the case now, right? So we're only going to get those opposites, right, when there's just x, so it's just x squared or it's just the absolute value of x. So you're going to have to set up these two equations, all right, and solve this. And this is really what I was kind of getting at when I was talking to you about putting down all your steps, because we're building to something bigger, right? And it seemed a little bit overkill at the time, but that was why. Okay, let's do problem 8 here on page 34 and then do a handful more. All right, now when I look at problem 8 here, it's an exponential, all right? And I can see that the main property here, once again, is multiplication, right? 5 times something is 45, right? So I want to answer that question first, all right? And the answer is 5 times 9 is 45. So whatever's behind my pen, right, has to be 9. And so that means 9 to the x minus 2 has to be 9. Now, the question is, 9 to what power is 9, right? So we know 9 to the first power is 9. So that means this has to be equal to 1. So I'm going to say x minus 2 now, which is that power, has to be equal to 1. Now, once again, if you know those factors, some of you might be going, oh, 3 minus 2 is 1, so x is 3. You can just do that if you know the fact. If you don't know the fact, use your zero property, okay? So I can subtract 1 and subtract 1. I get x minus 3 is equal to 0. And now you can for sure see 3 minus 3 is 0. Okay, now, like I said in the video that you were supposed to watch prior to today's class, right, you already did problems 9, 10, 11, and 12. All right, so let's just go ahead and flip to page 35 here, and let's do a handful more here. All right, just to make sure you get a good feel, all right, for all of this. All right, so now looking at 13, right, so we can see that this is definitely a linear function, right? We just have our single x, no exponents, no bars, all right? So we're looking for one solution. I can also see that this is, all right, a multiplication problem. So I want to answer that multiplication fact first, right? So negative 3, all right, times what is 27, all right? And so I know it's got to be negative 9. Negative 3 times negative 9 is 27. So whatever's behind my pen has to be negative 9. So now 4 minus x has to equal to negative 9, all right? And so now, if you don't know the fact, get it equal to 0. All right, so I'm going to add 9 to both sides, and I get 13 minus x is equal to 0. Now, 13 minus what is 0? And that would be 13. And there's our answer. All right, now, looking at problem 14. All right, problem 14, we can see that this is an absolute value problem, right? We get our absolute value bars. We're expecting two solutions. All right, now sometimes those two solutions are opposites, 5 and negative 5, 8 and negative 8. Sometimes they are not. So what we should be expecting right now, since we see more than just x inside our absolute value bars, is that they may not and probably will not be, all right, opposites of each other. All right, so now once again, I can see that the overall operation here is multiplication. So negative 4 times what is negative 12? And the answer to that multiplication problem is 3. So I know everything behind my pen has to be 3. So that means the absolute value of x plus 2 is equal to 3. All right? Now I go inside the absolute value and I have to ask myself, okay, what numbers have an absolute value of 3? And the answer is 3 and negative 3. But notice what's going to be equal to those two numbers, right? It's not just x, it's x plus 2. So x plus 2 could be positive 3, x plus 2 could be negative 3. All right, and then now, once again, if you know the fact, answer it. If you don't, use the zero property, all right, to get it to what you need. So I'm going to subtract 3 from both sides. X minus 1 is equal to 0. And then I know 1 minus 1 is 0, so my first solution is x. And notice if I plug x back in, right, I get 1 plus 2, which is 3. The absolute value of 3 is 3. Now, if I come over here and use my zero property, I'm going to add 3 to both sides. All right, x plus 5 is equal to 0. All right, and then I know negative 5 plus 5 is 0, so my second solution is negative 5. And then notice if I plug negative 5 back in here, I get negative 5 plus 2. Negative 5 plus 2 is negative 3. Well, what's the absolute value of negative 3? The absolute value of negative 3 is 3. All right. Okay, moving on to problem 15 here. Okay, let's look at this problem. And we know that from the problem that it has a power of 2 here. So this is a quadratic. All right. And now, once again, we're looking for 2 solutions. Now, I can see that I need to answer a multiplication question here. 5 times what is negative 45? All right, and the answer is negative 9. So whatever's behind my pen has to be negative 9. So x minus 5 squared has to equal to negative 9. Now, what we know is that something squared can never equal to a negative number. So I don't have to do more work, right? If I have this situation, we know it's going to be a no solution problem. All right, let's look at number 16 here. Looking at number 16 here, we know this is an exponential. All right, I've got an x in the exponent. And I can see that I have a multiplication problem. So I want to answer my multiplication fact first. 2 times what is 18? 2 times 9 is 18. So whatever's behind my pen has to be 9. So 3 to the x minus 1 has to be equal to 9. Now I have to figure out what power of 3 gives me 9. So 3 to the 0 power is 1. 3 to the first power is 3. And then 3 squared is 9. So what I know is that x minus 1 has to equal to 2. All right, so x minus 1 equals to 2. All right, 3 minus 1 is 2, so I know my answer is 3, or if you do the 0 property, you can subtract 2 from both sides. All right, and you can see that you do get 3. All right, so let me go through a couple of division problems first. Let's do 18 and 19, and then hopefully you feel good about the rest of them. And I want to do these because of these negatives kind of floating around here and that they're division. Now, anytime you have this negative kind of floating around here, what I suggest is put it wherever there's a constant, wherever there's a number. So since there's a 5 here, I'm just going to take this negative, and I'm going to move it from being out front, and I'm just going to put it in the denominator with that 5. And it doesn't matter where you put it. You can put it in the numerator. You can put it with the denominator. As long as you have one negative, the whole thing is negative. All right, it doesn't matter if it's out front, up top, in the denominator. All right, but I think it's simpler if you put it wherever the number is. All right, now the second thing here is that we know this is absolute value, so I'm expecting, all right, 2 solutions. Now, looking at this, we now see that we have a division problem instead of a multiplication problem, so we want to answer that fact first. So now I'm going to cover up my numerator here and ask myself, what number, when I divide it by negative 5, gives me 1? What we should know from some of our math knowledge, right, is that anything divided by itself is 1. So negative 5 divided by negative 5 is 1. So whatever is behind my hand has to be negative 5, and that would be the absolute value of x minus 6. All right. Now, just like I was saying before, we know that an absolute value of anything can't be negative. All right. So this means it's a no solution. Okay, one more together here, and then you'll be off to do your independent practice on page 36. All right, now when we look at 19 here, you can see that the negative is already with the 9 here. It could have been floating out here out front. All right. And so that's why it's okay. So we can, if it's out front, just move it to wherever that number is. Now, once again, we see that this is a quadratic. We're expecting 2 solutions, all right? And we can see that the problem is a division problem, so we want to answer that fact first, all right? So what divided by negative 9 is positive 4, all right? And the answer to that is negative 36 divided by negative 9, all right, is positive 4. So whatever's behind my hand has to be negative 36. All right, so that means that 2 minus x squared has to be negative 36. Now, once again, right, we know that anything squared can't be a negative number. All right, so once again, this is a no solution problem. All right, so please use your time wisely. All right, finish up. All right, the independent practice, which starts on page 36. All right, complete all those problems. Keep up with your exit tickets. Remember, go back in if you don't get full scores. All right, get those perfect scores for me, and then hopefully I will see you guys on Friday. Take care.